Welcome to the video on trenching, an intermediate solution for fecal sludge disposal. In this module, you will learn what is trenching and the process involved in it, design considerations, types of trenches, the operating and monitoring parameters, and finally, the advantages and disadvantages of trenching. Trenching is a disposal technique where the trenches are dug in the ground, which is later filled with fecal sludge and then covered with soil. This technique is implemented in areas which lack elaborate treatment infrastructure as an intermediate or transitory solution. It is clear that trenching is a recommended alternative instead of direct disposal onto open ground or water resources. Now, let's understand the process involved in trenching. The first step in this process is to identify a suitable site. The trenching site needs good soil permeability that allows easy leaching of the percolate from fecal sludge, has a flat surface for easy operations, is at least at a distance of 500 meters from human habitations, is far away from the surface or groundwater resources, with least possibility of trespassing by humans and animals, and does not have any vegetation on it. A trench site is always selected based on the estimated load of current and projected fecal sludge. Also, remember that the trench site should not be a shallow or flood-prone area, used without the legal permission and approval of respective authorities. Once identified, the site is cleared of any debris or scrubs, and the layouts are marked for the trenches. After that, the trenches with specified dimensions are dug with an excavator or manually. Then, fecal sludge is dumped and allowed to dry for 2 to 3 days. Finally, the sludge-filled trench pit is covered with the local soil. Trees can be planted on top or next to these covered trenches. So, what are the design considerations of trenching that we need to consider? Let's find out. Trench design depends on a number of factors such as soil type and quantum of sludge. The horizontal distance from the sides of the trench and water source should be 9 times the depth of the pit, or 45 feet, and the vertical distance between bottom of the trench and groundwater table must be 15 feet, or 3 times the depth of the pit. The access roads to the trenching site and inner road between the trenches should be designed properly for easy movement of trucks. The site is fenced to protect trenching area. Trees can be planted along the fence to reduce the odor and improve aesthetics of the site. Warning signage can be placed appropriately. Now, let's learn about different types of trenches. Trenches can be classified as 2 types based on their design and depth: shallow trenches and deep road trenches. As name suggests, shallow trench is dug at lower depth. They are recommended in the places where there is availability of land, unavailability of mechanical excavating infrastructure, and higher water table. This can be implemented in peri-urban and even denser areas if adequate space is available. As you can see, the shallow trench requires careful design. The top width and bottom width of the shallow trench must be 0.3 meters, while the height or depth of the trench must be 0.4 meters. The distance between the 2 trenches should be 3.5 meters. The length of the trench must be 10 meters. The trench pit can be covered with local soil. On top of the soil cover, high nitrogen demand saplings can be planted. These plants utilize the nutrients present in the fecal sludge for their effective and healthy growth. Deep trenches are used in the places where land availability is an issue. Unlike shallow trenches, deep trenches are further classified into normal deep trenches deep trenches with sand barrier, deep trenches with sand barrier, and agricultural film cover. The types are based on the distance of trench site to surface level water bodies and groundwater table. These normal deep trenches are constructed in the areas where there are no surface water sources nearby and the groundwater table is very deep. In situations where the depth of groundwater is equal to the permissible limit, deep trench with sand barrier is recommended. The permissible limit is generally 3 times the depth or 15 feet, or it is marked as per the locally prescribed guidelines. The sand acts as a protective layer to prevent contamination of groundwater. When both the surface water and the groundwater are almost equal to the permissible limit, deep trench with sand barrier and agricultural film is recommended. To prevent contamination due to leaching, there is a sand layer at the bottom of the trench, while agri-film covers all the sides. This prevents seepage through the sides and diverts the leaching through the bottom sand layer. Like shallow trenches, deep trenches require careful design. The horizontal top width of trench must be at least 5.5 meters. The horizontal bottom width must be at least 1.5 meters, and the width of the trenches should be at least 3.5 meters. The slope of such deep row trenches should be at least 1 horizontal to 1 vertical. The height or depth of the trench should be between 1 to 2 meters. The length of the trench should be around 10 meters. After following the normal trenching process, these deep trenches are covered with the local soil. Once it is covered by the soil, the buried sludge is left for at least 2 years for complete decomposition. After 2 years of burial, the decomposed material can be used as manure. Before using as manure, quality test must be carried out to ensure it is pathogen-free. Moving on, let's check the operating and monitoring parameters of trenches. Here are a few points that you need to remember while operating and maintaining trenches. Primarily, ensure that only fecal sludge from households is disposed into trenches, and no industrial, commercial, or toxic sludges are disposed. Next, let us understand the responsibility of trench facility operator. Every operator needs to refer to the operational manual to dispose the sludge as per design requirement. Follow standard operating procedures. Maintain log and records such as date or time of collection and disposal. Monitor the weather so that the sludge deposition is avoided during the rainy season. During rainy season, the leaching effect may be low. The frequency of dumping in the same trench can be lowered down. Use more than one pit during rainy season. The final operating parameter is safety. Safety is a major issue in fecal sludge disposal. All personnel should use adequate and proper safety gears and must undergo regular health checkup. During the monitoring phase of the trenching sites, the soil samples around the trenching site are tested each year to prevent contamination. Also, test boreholes are installed 100 to 150 feet away from the trenching site to collect and test the water samples to make sure there is no contamination. Like other fecal sludge treating techniques, trenching has its own advantages and disadvantages. Let's take a look. Trenches are easy to construct and are inexpensive. Planted trees over trench sites increase green cover while contributing to restoring the balance of carbon sinks. It also provides economic benefits from the produce and controls soil erosion. The sludge treatment technique also has its disadvantages. It requires a lot of land area, which is limited in towns and cities, and leaching from the trenches can pollute the groundwater and the surface water bodies when they are close by. Adequately planned, designed, operated, and monitored trenches produce no visible nuisance or bad odor. These components covered in the video can equip us with the knowledge required to implement trenching as an intermediate solution for fecal sludge management in India. Thank you for watching this video.